Hey guys, what's up? This is AJ of Bridging Code, and for this tutorial, we're going to build a truly serverless REST API in AWS using Node.js and the Serverless Framework. If you're watching this tutorial, I'll just assume that you know what Serverless Framework is, or familiar with it to some extent. But just in case you're not, Serverless Framework, or better known as just Serverless, is a new way of building and deploying your serverless applications quickly with relative ease and less manual work. They support a variety of cloud computing providers, including the top three companies, which are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. So what we're going to do today is to write a RESTful API with Node.js and use the serverless framework to define the CloudFormation stack that we will contain the AWS resources or services that we will utilize and deploy it over to AWS. Our REST API is going to be a to-do app which will create a task, list down all the created tasks, get, update, and delete a task through Lambda functions, and store these tasks in a DynamoDB table and expose this REST API through AWS API Gateway. Now, before we get started with everything, please make sure that you already have Serverless installed on your machine. If you don't have it installed yet, I have pasted a link to the instructions on how to install Serverless. For me, the easiest way to install it is to run npm install-g serverless on your command line or terminal, assuming you also have Node installed on your machine already, which you should, since the app that we will be writing is in Node.js. Besides this, you will also need to configure your AWS credentials if you don't have it configured yet with the AWS configured command, and enter your access key ID and secret access key, which you can obtain by creating a new user in IAM. For me, I just gave my user programmatic access since I don't have to log in to the console with it, and assigned it an administrator role since this is just a demo. But in reality, you would want to give your user a more restrictive access for security reasons. Now, to set up our project, we open our terminal and type serverless create. For this app, we will use a serverless template called AWS Node.js. And we also specify the name of our app project and the path. Now that we have that created, let's open this project on Visual Studio Code. And as you can see, here are the files that were generated for us by Serverless based from the template that we used, with the most significant file being the serverless.yaml, where we will configure the AWS services that we want to use or involve for this app, like DynamoDB, and of course the Lambda functions that will process our HTTP requests. But before we start working on this file, let's get some of the packages that we will need, like UUID to generate a unique ID for the task that we will save to DynamoDB, and of course the AWS SDK package for Node.js. Now let's go back to our serverless file and delete these unnecessary comments. First, under provider, I will set the region where I want to deploy the REST API, and that is AP-Southeast-1, or the Singapore region, because this is the region where I'm closest to. Next, Also, under provider, we will configure the role that our Lambda functions would have, which is to allow it to describe and query the DynamoDB table and get, put, update, and delete items in it. We will also set the resource to allow these actions for all DynamoDB table under the region we just set, which is AP-Southeast-1. Next is we will create a DynamoDB table and set the deletion policy to retain so that our table doesn't get deleted every time we build and deploy with serverless. We will also set the primary key of this table to be an ID of type string. Set our read and write capacity to just 1, since this is just a demo app and we don't really need that much. And name our table to-dos. Let's configure the Lambda function to create a to-do task here in the serverless file. Specify the path of our create to-do Node.js code. And this will also essentially create an API gateway trigger to invoke the Lambda. Now let's write the code to create a to-do task. We will import 2 packages, of course the AWS SDK to write the code to save the task to DynamoDB, and the UUID, which we will use to generate a unique ID for our task. We get the current date and time as an ISO string for the created and updated date of the task. Get the request body. Let's also check if the task we're trying to save is a string. If not, return an error response. Message task is not a string. Now let's set the params that we will pass to DynamoDB to create the task. Well, with the table name being to-dos and the item which is the task that was extracted from the event body. Date time, updated at, date time. Now we call DynamoDB's put function and pass over the params and a callback function. Return an error response if something goes wrong. Return. and return a successful response with the saved task. Data.items. Callback, null, response. Okay. Now, let's build and deploy this code over to AWS using serverless. By running serverless deploy, this may take some time depending on the speed of your internet connection or how close are you to the region that you are trying to deploy. Let's grab this API gateway URL that was created for us by serverless and paste it over to Postman to submit a post request. And then let's try to submit a task. JSON task do homework. Okay, it appears that we have successfully created a task. And if we go to DynamoDB table that was also created for us when we ran serverless deploy, as you can see, I was also able to save the task here. Next is we're going to configure a Lambda function that lists down all the tasks we created. And we're going to start off by copying and pasting this existing configuration. I'm going to rename this to list, specify the path of our list to do code, and this time it will be a get method. I'm just going to copy and paste this create to do file since they will be fairly the same. I'm going to rename this to list to do. Let's see, let's rename this to list to do, of course, and delete all that unnecessary code. Let's delete this too, since we'll only need the table name. And let's change this to scan. Now, ideally, you will want to design your DynamoDB table to be able to use the query function rather than the scan function because it performs more efficiently. But for the purposes of this tutorial, we'll just keep it quick and simple by using the scan function. If you want to read more about this, it's in the AWS documentation. Let's set the status code to 200. And finally, we return a list of the created items. Now let's build this code again. And as you can see, we now have a new API URL to get a task. Let's paste this over to Postman. And as you can see, it lists down all the tasks we created earlier. And if we create a few more tasks, eat lunch, another one, um, clean room. Let's try it again. And as you can see, it is able to list down all the tasks that we just created. Next is we are going to create the Lambda function to get a specific task using the task ID. So again, I'll just copy and paste this. Rename it to get to do, get to do. This time we're going to add a path parameter called ID that serves as the selector to get the task we want. So a get method. Again, to save us some time, I will just copy and paste this list to do code as they are fairly similar. Let's rename this to get to do. For the params, besides the table name, we will also need to specify the primary key as selector, which is the ID, and we are going to get that from the path parameters. This time we will use this get function. For the response, let's return a status code of 404 if we didn't find any task with the specified ID. Message, task not found. Let's remove that UID since we don't need to generate a new ID. And let's build it. Oops, sorry, I forgot to rename this. Should be get to do. Okay. Let's build this again. And as you can see, this is the URL of the new get API that was created for us by Serverless. Let's copy this, paste it over here. Let's choose a task that we want to fetch and get this ID. And as you can see, we were able to get the task with the specified ID. Let's get another one. And there you have it. For our next Lambda function, it should be able to update a certain task. Let's rename this to update. Update to do. This time it will be a put method because we are updating an existing item. Let's copy and paste the get to JS so it's faster. Rename this to update to do. Let's remove that. Update to do. For this one, let's also check if done is still a boolean. If not, return an error response. Let's set in the key the ID of the task we want to update. And we put in the expression attribute values, which is a collection of placeholders with the updated value, and we only intend for the um, task and done attributes to be updatable. And of course, the update expression containing the placeholders in the expression attribute values. Let's call the update function having the same arguments as before. Let's change the status to 200 and return the updated task. And finally, let's build it again. And as you can see, this is the URL of the new put API. Let's copy this and paste it over to Postman. Let's again choose a task we want to update and get its ID. Let's delete that because only task and done will be updatable. Let's add the word done, and this should now be true. Seems okay. And let's get this task. And as you can see, we were able to update this task. Lastly, we also want to be able to delete a certain task. Rename this to delete, delete to do, delete to do, and of course, this time it should be a delete method. Let's copy and paste this, get to do code, rename it to delete to do. Everything will basically be the same except let's just hold on, let's delete function. We probably don't need that. Let's just return an empty object. Rename that to delete to do. Let's see. Let's build this code again. Let's go ahead and copy this and paste it over to Postman. Set to delete. Let's again choose a task we want to delete. Submit, submit. Okay, it seems that we have deleted the task. So if I try to retrieve this task, it's 404 and we didn't find anything because we deleted it. Lastly, I just want to show you what serverless created for us when we deployed with it. Lambda, API gateway. Of course, it first created a CloudFormation stack because this is the template containing the AWS resources we need. And here in AWS Lambda, here are all the 5 Lambda functions we just created for our REST API. And here in API Gateway, here are all the 5 endpoints of our REST API. So that's it for this tutorial. Hope you guys liked it. If you have any questions, feel free to drop them in the comment section and I'll be sure to make time and answer them. Don't forget to hit like and subscribe, and thanks for watching. Bye.